Section 1.6. In this section, we will investigate absolute value functions. Showing figure 1, distances in deep space can be measured in all directions. As such, it is useful to consider distance in terms of absolute values. Recall that in its basic form, f of x is equal to absolute value of x can be defined as a piecewise function. It is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. Let's have an example here. Figure number 2. It describes all values of x within or including a distance of 4 from the number 5. So let's say these are x values, and the distance from here to 5 is 4, and from here to your x is also equal to 4. Now, how do we solve for x? So the distance from x can be represented using the absolute value as x, absolute value of x minus 5. So we want the value of x that satisfies the condition absolute value of x minus 5 is less than or equal to 4. So how do we do that? So note that negative 4 is less than or equal to x minus 5, and x minus 5 is less than or equal to 4. So let's solve for x. If we add 5 both sides here, negative 4 plus 5 is 1. So that is less than or equal to x. And then we add 5 both sides here, 4 plus 5 is 9. So x is less than or equal to 9. So absolute value of x minus 5 less than or equal to 4 is equivalent to 1 less than or equal to x less than or equal to 9. That's why, look at the shaded part here. From here, so this is 1 up to 9. Next is graphing an absolute value function. So this is a graph of an absolute value function, a V shape. Last section you learned about the transformation of functions, and let's recall that. Figure 4 shows the graph of y equals 2 times the absolute value of x minus 3 plus 4. So remember this. The graph of y is equal to absolute value function of x, the blue one, and it has been shifted right 3 units. Look inside the absolute value, x minus 3, that is shift 3 units to the right, and then vertically stretched by a factor of 2. You have 2 outside of it, and then plus 4, that is shifted up 4 units. So when you do that, this is now your graph, and you will see that the corner point is located at 3, 4. This point here. So from the origin to the right 3 and then up 4, and that is the corner point at 3, 4. Next, Write an equation for the function graph in figure 5. So remember, this is a graph of an absolute value function from your toolkit or from the parent graph of an absolute value function. Something like this. From here, from green to blue, what are the transformations? So it looks like from here, which is your f of x, the red one, is equal to the absolute value of x. You move it 3 to the right and down 2. So you look, that's why you have a 3, negative 2 here as your corner point. So again, you move this graph from the origin 0, 0, 3 to the right and down 2. Is that right? And the next is look at the distance from here to here. 1, 2, 3, 4, 5, 6, 7, 8 units. How about here? 1, 2, 3, 4. So notice that this is twice of this. So how do we write an equation for that? So yes, it will be y equals 2 absolute value of x minus 3 minus 2. So again, 3 units to the right, 2 units down, and you have your stretch factor of 2. Next, do the graphs of absolute value functions always intersect the vertical axis? How about the horizontal axis? Let's start with letter A. Look at the V graph, which is the absolute value function. It does not intersect the horizontal axis. How about letter B? The absolute value function intersects the horizontal axis at only one point, at this point. And letter C, the absolute value function intersects the horizontal axis at 2 points, at this point and at this point. Next example, for the function f of x equal to absolute value of 4x plus 1 minus 7, find the values of x such that f of x is equal to 0. So that is f of x equal to 0 given f of x. So you can write f of x, make it equal to 0. So 0 equals the absolute value of 4x plus 1 minus 7. And then let's solve for x. First add 7 both sides. So that this is now 7 equals absolute value of 4x plus 1. And then to solve this, it is 7 is equal to 4x plus 1, or we're going to use the other side here. Negative 7 is equal to 4x plus 1. Solve for x. So subtract 1. Seven minus 1 is equal to 6, equals 4x, then divide by 4, and that is 1.5. The other one, subtract 1, so this is negative 8 equals 4x, then divide by 4. Negative 8 divided by 4 is negative 2. So the function's outputs 0 when x is equal to 1.5 or x is equal to negative 2. Look at this. Look at the graph. You have the points at negative 2, 0, and 1.5, 0. Should we always expect two answers when solving absolute value of b? What do you think? The answer is no. We may find 1, 2, or even no answers. So for example, two plus absolute value of 3x minus 5 is equal to 1. If you subtract 2 both sides, that's going to be the first step. It's going to be a negative number. So whenever you have a negative number on the right side, then you stop and there will be no answers. Okay, so it's possible that there will be no answers. Next example. Solve 1 equals 4 times x minus 2 plus 2, and then we're going to graph it. So let's do the same thing here. The first thing that we do here is subtract 2. That's correct. So subtract 2 both sides. So this is now negative 1 is equal to 4 times the absolute value of x minus 2. And then we can divide it by 4 both sides. So negative 1/4 is equal to the absolute value of x minus 2. What can you say here? Again, this is a negative. So meaning no solutions. All right, take a look at this. If you take a look at this, the right side of this equation, 4 times the absolute value of x minus 2 plus 2, that is the same as this. And if we graph it, it's an absolute value. Look at the transformations here. X minus 2, meaning that is 2 to the right, up 2, and you have the stretch factor of 4. And based on this V graph, the absolute value graph, look at 1. When y is 1, there's nothing here. You see a horizontal line here. It's not touching this graph. So that's why you have no solutions. So that is to answer example number 5. If f of x is equal to 1 and g of x equal to 4 times the absolute value of x minus 2 plus 2 were graphed on the same set of axes, would the graphs intersect? No. So when they do not intersect, then no solutions. Next example. Absolute value of x minus 5 less than 4. To write this and solve for x. So x minus 5 is equal to 4 and x minus 5 is equal to negative 4. If we add both sides 5, that is x equals 9 And if we add 5 here, negative 4 plus 5 is equal to 1. So that's why, based on this graph, this is the graph of f is below or on the graph of g. That is your x values from 1 to 9. So that is the graph satisfying the absolute value inequality. Next one. Given a function f of x equal to negative 1/2 absolute value of 4x minus 5 plus 3, determine the x values for which the function values are negative. So since it says here, find the x values for which the function values are negative, so we want this function less than 0. So we could write this as negative 1/2 absolute value of 4x minus 5 plus 3 is less than 0. Let's solve it. So first, subtract 3 both sides. Less than negative 3, and then you can multiply both sides by negative 2. So absolute value of 4x minus 5. When we multiply by negative or divide, you change the inequality. So this is now greater than 3 times 2 is 6. So then again, 4x minus 5 is equal to 0. Oops, sorry, 6. Or 4x minus 5 is equal to negative 6. Let's solve for x. So add 5 both sides. So this is 4x is equal to 11. So that x is equal to 11/4. The other one, if we add 5 both sides, 4x is equal to negative 1. And if we divide 4 both sides, x is equal to negative 1/4. And take a look at this graph here. You have 11/4 here and negative 1/4. And everything below the x-axis. It crosses at those values of x, and those are below the x-axis. And that is section 1.6. Thank you.